Hello, this is Electronic Careers and Education. My name is Ken Masanko. I thought I'd introduce myself a little bit before we get started here. I graduated with an associate degree from Erie Institute of Technology in 2001, and I've worked at several contract manufacturers. I've been working in the electronics industry for over the last 10 plus years, between 10 and 12, roughly. I was a technician at a couple places, engineer at a couple more. I am currently working at General Electric Transportation, working on my bachelor's degree. I'm an apprentice there. They put us through school, so I'm working on my bachelor's at PSU Barron, working towards ECET. Okay, so let's get started. Basically, there's 6 sections we're going to take a look at. The first section, past developments. Basically, we're going to look at the most significant ECET development over the last 3 years, 3 years of the past. Section 2, future developments, we're going to look at the exact opposite of that. Most significant ECET development over the next 3 years, what that's predicted to be. Section 3, societal issues. We're going to look at the most significant global/societal issue facing the ECET field. Section 4, career losses. We'll take a look at ECET jobs/careers that have been lost over the last 10 years. Section 5, potential careers. The glass is half full side of that. We're going to look at new ECET jobs and careers expected over the next 10 years. And then in Section 6, a little lightheartedly, we're going to look at my personal ideal job, based off of reality, not fantasy. So, first section, most significant ECET development over the past 3 years. I think several people have different opinions on what these things could be. But in my looking and my research, basically one of the big developments over the last 3 years is nanotechnology. Nanotechnology is used much for frequent and complex circuits. Nanotechnology is actually the engineering of functional systems at the molecular scale. Nanotechnology has applications in many fields. What we see is nanotechnology being used in medical fields. We're fighting diseases, preventing health problems. We see it in military, being used for warfare. And we even see it in consumer products. They are developing products that can actually heal themselves when broken. The technology is getting smaller and smaller everywhere we look. Another significant development over the last 3 years is package on package, POP for short. Basically, package on package is when you take they're called BGA components, ball grid array. They use small balls of solder to adhere to the board, and you actually mount to another BGA that's already mounted to the board. So you'll have several stacked, as you see in the picture here. It's used in surface mount. It's increasingly complex. One of the benefits is it provides high potential and a very small footprint of the PCB, which is a printed circuit board. You'll see you only have so much room to print. Like I said in the last slide, our electronics are getting smaller and smaller. So space is an issue. So if you're able to stack components, especially complex components like these BGAs are, the real estate is not that much available. So it's very beneficial to be able to stack these components. You need very precise equipment to manufacture this type of. The most significant ECET development over the next 3 years. One of the it's a late development, but it's just kind of getting off the ground here. You've probably heard 3D printing. It's becoming more and more a reality. 3D printing opens a world of manufacturing possibilities. It's used to be used, it's been around for a little bit. It used to be used only for prototypes, and that's kind of what they primarily thought that the use of this would be. But the products that they're able to create are very complex objects in a short amount of time, and they have the ability to make complex products lighter, faster, and stronger. So that is definitely a benefit. That I think will be significant over the next 10 years is flexible electronics that are wearable. Wearable electronics are actually not as cheesy as they may sound. There's many applications. Products that can be charged, maintained through the power generated by circuitry lining on a jacket or a shirt. They're working with electronics that, like phones and things, that you wear a special type of jacket or shirt, and just the movement with the electronics embedded in your jacket or shirt actually provide power to these products. These products can also be used not so much as just a power source, but they can be used to determine things by the military, watching your vitals, firemen, policemen. Products that are specifically designed with the wearer's health and safety in mind, detecting and reporting when there are threats imminent. The most significant ECET societal issue, contrary to the title, I'm not sure if this is the most significant, but it is something that the industry is facing. The move to lead-free solder. You may have heard of RoHS. Some people call it RoHS. It's the removal of hazardous substances. That's a committee that they're pushing. Firstly, it started in Europe, and it's made its way across to the States, trying to get rid of leaded solder out of our electronic equipment. The problems with solder, you have lead getting into your environment and drinking water when we dispose of our products. So this moving to lead-free is supposed to be good for the environment, better for the environment than what they normally use. One of the issues, however, with going lead-free is tin whiskers. The primary product used in most lead-free solders to replace lead is tin. The number one problem with lead-free is the production of tin whiskers over time. These microscopic whiskers, that's why they're called that, form on these tin lead-free joints, and anything that solder is on, it's not actually solder, but that the lead-free solder, and it forms these whiskers that will short the problems. They start as a perfectly fine joint. That's what you start with. And eventually, when you grow these whiskers and you end up shorting your product, it has the ability to destroy the circuit. Even in a perfect situation, lead-free is more difficult to work with from a manufacturing standpoint. So, in addition to these whiskers, just producing when you start from scratch, lead-free is harder to work with. It doesn't wet as well. It tends to stay where it's placed on the pads. It's not as forgiving for reflow. So it's difficult from a manufacturing standpoint, and I have firsthand experience with that. ECET careers lost over the past 10 years. Many manufacturing jobs are being shipped overseas. I think a lot of people realize that, know that. Line workers are hit the most due to cheaper labor in other countries. One of the effects of this is, even though your engineers may not necessarily be on the line, the more companies move their production outside the U.S., the less jobs here for the engineers to work. Your engineering support for a company, If the company's not here, the work's not here. So, it reduces your opportunities for engineers. Although production jobs are low, the U.S. continues to produce more goods than any other country, followed by China. The other factor causing the reduction of these positions is automated production. We are going smaller and smaller with more precision that can not be obtained by human hands, forcing the move to robots. The more robots you use, the less jobs we have here. And like I said, that's tied directly with the engineering jobs if you don't have the jobs here stateside. Luckily, these robots need programmed to do their functions, so that gives engineers at least a little work. New ECET careers for the next 10 years. One of the things that we're constantly hearing about that's going to pose new careers is the energy crisis. The push to stop reliance on fossil fuels is cause for great innovation. There's a tremendous opportunity to increase efficiency here. The field is loaded with opportunities for our best and brightest to come up with reasonable solutions. There's always this threat of global warming, and you have both sides saying that it is real, it isn't real. Either way, we do realize that we have to at least reduce our reliance on fossil fuels without necessarily cutting ourselves off cold turkey. And that's going to have an opportunity for careers. The other is, we discussed for the future, flexible electronics. This is another opportunity for development. Even though the field has made great strides in recent years, there's still so much further this science can be taken. Everybody wants to go smaller. Smaller devices that use less power. Nobody wants to wait for batteries to charge and things like that. So this is a huge opportunity for careers. My ideal job. This was actually a tough one because I truly think that several jobs can be my ideal. But I had to pick something to go with. Factors that I thought about when considering my ideal job is something that's constantly changing, constantly challenging, because I want to stay away from the mundane. I don't like the same thing every day after day after day. Cutting edge technology. I love my technology. I need to be working with the latest and greatest. And a great team of people. I love working with people that contribute and just great minds. People can make a world of difference when it comes to a job. So my ideal job would be have a flexible schedule. I'm not necessarily a morning person. However, it's nice to get out of work early here and there. So I love the idea that something that's a little flexible. Equal parts thinking and working with hands. As much as I enjoy a good brain teaser, I love to accomplish things with my own two hands as well. When you're actually solving problems with your mind, but then also putting those ideas and those new things into use and being able to develop something with your hands, is just nothing pays off like that. And something that's lucrative. There's just something about stepping back, and look at what you've done, and then also being able to live off that, having something that you can get money from and enjoy. So I looked at a guitar design engineer. I found out a few things about it. Being a musician, I attempted to pick something that I can bring my love of music and my love of electronics together. This is a job that somebody has to do, so why shouldn't it be me? Parts can easily be done from anywhere in the world if necessary. So on the design side, you do a lot of stuff with software and cutting edge technology like that. That would allow you to do work from home, work from, if you had to go, you can work from anywhere in the world with the design side of it. You get to work with experts in the field, including legendary musicians. Designing guitars, you would get to have people come in and try those out and tell you what they like and dislike about them. The tools involved would range from simple woodworking tools to state-of-the-art software and sound equipment. This really gets to, where you get to get tactile with it. You get to actually experience it and use simplistic tools, yet also the technology side of it, where you're using state-of-the-art software and the equipment to test and frequency and all that type of things that you'd be looking at. Spending time trying to make improvements to designs that have been around for decades, that's a wonderful perk. I mean, guitars are not a new product, but there are ways to improve. They've been improved over the last, so many years. There's no reason to think that they can't still be improved in different ways. And decent pay with phenomenal perks. Like I said, something that would pay well, and just the perks are everything that I listed above there. In this job, I feel like you cross the threshold from producing products to producing actual instruments in every sense of the word. I mean, these are precision instruments that are not only precise, but they're art. You're creating art. And I just love the thought of crossing that barrier, getting back and forth between art and science. It appeals greatly to me. Well, I hope that you enjoyed my slideshow. I highly recommend a career in ECET, and I thank you very much for your time.